Hi, and welcome to another episode of my Hopper hardware project, my 6502 single port computer. Let's get on with it. I'll give you a status update of where the hardware is. So let's show you where we came from. So started with a breadboard prototype. So, tip of the hat to Ben Eater. And while we're at it, Grant Searle and also Garth Wilson, because they're the ones who've sort of got us all going on this and have come up with most of the sort of variations and permutations on the designs of these little onboard 6502 machines. I got my PCBs made by these guys. It's not like they sponsor me or anything, but I'm very happy with their service. And it's not my first project I've done with them. All right. My first board was this one, which I made lots of mistakes on, but it was a good learning experience. And I put everything in sockets so I can reuse all components. My second board was this one. Still had some bodges on the serial port, but other than that, it's a big improvement. I got the serial EEPROM working, the I2C serial EEPROM, and I got the LCD working, the OLED display working as well via I2C, so that but the serial EEPROM is kind of nice, so that with Hopper you can store your Hopper program on it. You can persist a program much like you can with an Arduino. And then this is what I'm hoping is the final version for now. So let's go reset button, restart the program. So this one is actually running the little early display. I've got a little game controller on it through the via, and it's also underneath there. It's got the little serial EEPROM to store the program, so that if I pull the power, if I pull the power on it and then restart it, it starts the program up again. Yeah, so it can persist your user program much like an Arduino could, as you would expect. Anyway, let's get on with discussing the design. So on the side of the board here, it's powered by the USB port. So this is one of those FTDI cables that goes straight into a USB port. And the wiring on these is relatively standard, and you can rely on the little on the black wire to be ground and the red wire to be your power. So that's what these markings. If left of, I'm going to actually use a different board in a second, but that's what's on the left of the little yellow pins is the pinout for one of these, which is fairly standard. But in addition to this, I've also found other devices that commonly used FTDI style devices. And I've found two pinouts are quite common. This is one of them. This is a WaveShare device. I like this one a lot because it's got a USB-C on it. And another thing that's important is to make sure, like this FTDI cable, it comes in two versions. It comes in the 3.3 volt version or a 5 volt version. And for 6502, you want the 5 volt version, obviously. These two devices, this one's got a jumper to switch between 3.3 and 5. And this one actually has a little switch to switch between 3.3 and 5. And the pinouts are written on the boards. And I put these edge connectors on with thinking it was going to be an angled connection like that. So that's the Velleman one, which you can get this one from Jameco and a couple of other places. So it's a commonly accessible one. And this is the WaveShare one, which you can get just about anywhere, like from Pi-Hut or anywhere, or from WaveShare themselves. So these are all the same. You only need one, obviously. And it's designed so that you can just use some off-the-shelf FTDI device as the serial port on your USB cable, and it should just plug straight in like that. But I would still check the pin out, because the one thing I might modify in a future design is to put a diode in here to make sure, like if you put in the power backwards, it'll still work. Like, in theory, you could easily you could plug this in backwards. And I'm hoping with these you're less likely to, because they're on the angled connector. You're going to put them sort of the obvious face up way because the components are on top. Right. This particular board, I've got the UART running at 28K. If you double the speed of this clock, you can just get it twice as fast. Or you could do it in the firmware as well, but with the same firmware, you just change the clock and the speed changes. And I've got it running at 8 megahertz on this on the CPU crystal. There is a jumper in there to run on one can, so you can put in a jumper in here and run the CPU off the same can as the UART. But I like trying to max out the CPU speed without compromising on without, there's no counter in there or anything. So let's talk about how what this board's made of. I've got the schematic. It'll be up on it's up on GitHub already. It's got this is revision 1.2, so I'm probably looking at the wrong one right now, but it's got 4 pages, CPU, the VIA, which is the versatile interface adapter, which is a Western Design Center product. It's just I use it for 2 I/O ports, and I use it for the timer, so that so that Hopper can tell, can have a millis kind of function. Next one is the serial port, and I like the Motorola 6850, as I've mentioned many times before, because it's bug free, and it only requires 2 bytes on my 0 page. I've mapped my I/O devices to the 0 page, so the VIA takes up 16 bytes on the 0 page, and the serial port takes up 2 bytes on the 0 page. And then for memory, this is the EEPROM and the static RAM. In addition, there's this serial EEPROM. Now let's talk about those. Let's switch back to the PCB. So in the same way that I'm making it so that you can use like a variety of components, so you can use 3 different pinouts for your FTDI. This little serial EEPROM, I've tested it with 3 different sizes of EEPROMs, so they're all very similar in their pinouts, and this pinout works for all of them. I got the idea of putting this little I2C header on here from Anders Nielsberg from his 650 Ueno to run the little so that you can just plug this in directly. These little OLED modules, not very retro, but they're kind of nice to be able to debug with. Yeah, so that's what that header's about. It's pretty straightforward. For every single, I decided to use CAN oscillators instead of crystals, but in both cases they support both a DIP8 pinout and a DIP14 pinout. I didn't number any of the components. I just put their values on board directly, and for the diodes, there's like a little image so you can see which way around to put them in. What other features does this board have? It has a little supervisor here, a 5-volt supervisor circuit, which gives you a well-controlled power up. It holds the reset line down for about for 150 milliseconds, so that you get a clean start for all the more than one of these chips to use the reset line. And this reset, there's a reset button to force that again. So it's not like a Raspberry Pi Pico where you have to plug the thing out and plug it in again because they were too cheap to put a reset button on it. On previous designs, I never had a non-maskable interrupt button, which I regretted not having. So on this one, I have a non-maskable interrupt button, and it is debounced as well. And I use that for my brake button in my debugger in Hopper, which is really nice. So you don't have to poll, like when you're running in the debug, you don't have to check on every instruction, did the brake button get pressed? You can just use the NMI instead. I mean, I remember that in the old days where computers used to have brake buttons, it's still called brake on your keyboard, or, it's like on the pause button on a regular keyboard, there's a word brake, but it doesn't brake anymore. So it was nice to use a non-maskable interrupt. I needed an extra button once I installed the serial EEPROM, and the reason is that Hopper will automatically boot and run the program that's on the serial EEPROM when you repower it or when you reset. And if you've got a bad program that just sends Hopper sideways, it means you brick your board, and it'll just keep booting into that program and failing, and you might not be able to connect with the debugger. So you can unbrick it by just unplugging it, because it uses a sort of a plug and play. Like at startup, it checks to see if it can find these on the I2C address bus by address, and if they're not there, it doesn't use them. But the easier way to do this is this is like the boot select button on a Pi Pico, but it does the opposite. So you hold it down during reset, and then you press reset, and if it is down during reset, then it won't boot. So it's the don't boot select button. And the only other, and it's connected to port A1, I believe, whereas the built-in LED, this one here, is connected to port A0. Yeah, and there's a little power LED here, and that's that. Then I've designed it so that you can use either the MOS or the Western Design Center 6502, so the newer one or the older one with more or less instructions. And you've got these two jumpers here to, you put the jumper in for the one you want. So I put jumpers in like resistors, they're just 0 ohm resistors. So you, looking at a board, you just put a jumper in like that. Yeah. So there's 3 jumpers on the board. That one, the one for the Western Design Center chip, the one for MOS one or Rockwell, and the one to have a single clock. I figured, you know, I got that idea from Erturk, who does the 8-bit force shields. He had done that with his 650T2 shield. He'd made it so that you could plug either of them in. Because they're not exactly pin compatible, they're pretty close. Next thing, for the EEPROM, thankfully there's some compatibility as these things grew. So this is for the 32K one, but you can also put an 8K one in. I really wish there was a 16K one, because the Hopper runtime currently really needs about 16. It doesn't quite fit into 8 anymore, the minimal runtime for the 6502. For RAM, I added 2 extra pins. So let's have a look at that. 4 extra pins. So if you look in here, that's with the 32K RAM chip in there, but it's got 4 pins, extra pins. And I got this idea out of someone on the Discord, on Anders's Discord server, the 65Uino Discord server, mentioned that there was this other RAM chip that had this, it's got this brilliant pinout where you can just interchangeably, you know, they added, because the power pin's up on this end. So all they did is they made that another chip select, a positive chip select, and they put the power pin up there. And then they added 2 more address lines. One of them's a, you know, not connect, but, and by doing that, they expanded it from being a 32K ROM to 128K ROM, RAM, SRAM. And the intention here is that I haven't gotten it yet. They're in the mail. The intention here is that if I use only 16K of the EEPROM, I can have 48K of RAM for Hopper. And how can we do this after we've made the board? Well, I've used CPLDs for doing my glue logic. So this space here. So, and currently I'm running on the little one, which has only got 8 cells in it, 8 macro cells, the GEL 20V8. But I've also tested with the 22V10, which is a more common CPLD. So I use these as the glue logic. So you can, it's fun to program them too. And I've got a Hackster article on how you do it. But I've tested so that I can run with either of these 2 GELs. And I've also tested so that I can map differently, so that I can have, right now I've got 32, so 32K of EEPROM and 32K of RAM. But I've also tested mapping it so that I have 48K of RAM and 16K of EEPROM. And you just do it by programming the GEL and replacing it. So it's a good idea to keep this one in a socket. I'm not sure what I'm going to keep in a socket on the final boards. I'll definitely always keep the EEPROM in a socket. I've found these are really nice little sockets, these guys. Super slick. So let's see if I can get that back in. There we go. Yeah. Because I've used these ones before too, but they're a bit bulky. So I this is my first time using these ones, little flat ones, and it's really nice. I left enough space around it so that I could use the bigger one as well. It was quite a trick to get this board to, with the free routing software, Easy EDA. It was quite a trick to get this routed for a 10 centimeter by 10 centimeter board. And the reason you do the 10 centimeter by 10 centimeter board is because these guys make those for like $2 for 5. So it costs way more. The shipping costs way more than the board. Yeah. Anyway, I'll put the design of the board up as well, so anybody can build these. So the idea behind this board was that anybody could build it, so it doesn't have any surface mount components. So if you've got old shaky hands like I have, or your vision's not as great as it could be, like mine isn't, you can still easily build this board. It's got 3 little holes for feet as well, and they're 3 mil diameter, so that you can put like a nylon 3 mil screws in them and mount them into something if you want to. I just leave it on the table. I have had this habit of, I've made this habit of always running my board on a piece of cardboard. So typically when I power up, I didn't have it that way earlier, I typically power up on a piece of cardboard. And that's, well, 2 reasons. One is you don't scratch the desk, and the second is you don't want to put this thing down on metal by mistake. So I like my cardboard landing pad for this thing. All right. I think let's power it up and get our little game started again, and then I think I'll fade out of here. So I will do more on this. I'll probably more on really just it's so that little game running there now. I've got other videos on this, sprites for this game. It's my game controller running left and right down there. I'm still working on the Hopper minimal runtime for 6502. Busy adding a couple more types to the minimal runtime, like floats and longs, and then I'll do lists and dictionaries as well. So right now the only reference types are strings and arrays, but it'd be nice if they were all there, and I think they're all going to fit into 16K. So I'll keep moving forward with that, so that we end up with a pretty awesome development platform for this board. And the debugger, the full debugging environment just works via the serial port. So you can do this, step-by-step debugging, watch your variables, all that. It's really nice to work on. Anyhow, that's the hardware update. I'm pretty happy with this board. It was uneventful putting it together. Just soldered all the bits on and booted it up. Thank you for watching.